In this video, we're going to be testing the claim about a mean where sigma is unknown, and we're going to be using the critical region method. This is the formula for the test statistic, but we're not going to use it. We're going to use our calculator, but if you want to calculate it by hand, this is the formula you'd use, and this is what everything means when it comes to the formula. Be very mindful, you do need to know what DF stands for the degrees of freedom, because that is relevant whether you use a calculator or you do it by hand. So in this example, the NHTSA conducted a crash test of child booster seats for cars. Listed below are the results from those tests with the measurements given in HIC, which stands for Head Injury Condition. 774, 649, 1210, 546, 431, and 612. The safety requirement is that the HIC measurement should be less than 1000 HIC. Using a 0.01 significance level to test a claim that the sample is from a population with a mean less than 1000 HIC. Do the results suggest that all of the child booster seats meet the specified requirement? Well, we know that our alpha value is 0.01, and we are testing the claim that the sample is from a population with a mean less than 1000. So in our null hypothesis, we can say that the mean is equal to 1000. And for our alternative, we could say right here it says less. So we're going to be less than 1000. Now we need to find the critical value, and we find that from our alpha value. And we can see here that we do have 1, 2, 3, 4, 5, 6 numbers. So our n value is 6. So that means our degrees of freedom is 5. And this is a one-tailed test, left-tailed. So we're going to go to our critical values table. And since our alpha value, our significance level, is 0.01, and it's a one-tailed test, we're going to be in the second column. And our degrees of freedom is 5. So we're going to be right here at 5. And we're going to go over and see that our critical value is 3.365. But because it is a left tail test, we're going to say that's a negative 3.365. So our critical value is t equals negative 3.365. And now we got to find our test statistic, our t-stat. And we're going to do that using the calculator. So we're going to bring up our calculator. And seeing as we have a bunch of data points, we're going to plug these into a list. So we're going to go to stat and one edit and key in our 6 values, which I already have earlier. Make sure they're typed in correctly. Once they're all typed in, you're going to go to stat. We're going over to tests, and we're going to do t-test. And now we're going to select data because we have a bunch of data. And we're going to start typing in what we know. Well, the mean is 1000. We got that from a hypothesis. So 1000. Our list is L1 because that's where we put the numbers in, or put whatever list you put the numbers in. Frequency stays 1. And our null or alternative hypothesis is less than. So we're going to go and select less than. And then we're going to hit calculate. It's going to think about it, and it's going to spit out a number, t equals negative 2.661. So t equals negative 2.661. If you did not want to use your calculator and you want to actually do it by, if you don't want to use a t-chart and you wanted to use a calculator to find the critical value, what you would have to do is you would have to go to second vars, and you're going to select inverse t, and there for the area, you're going to select 0.01, and then for the degrees of freedom, you're going to select 5. And since it's a left-tailed test, make sure we use a negative number for our t-stat. But in any case, we now have our t-stat, we now have our critical value for the critical region, so we can use the critical regions method. So in our little graph here, let's see whether we reject or fail to reject. Negative 3.365 for the critical value is going to be somewhere over here. I'm just going to say right here. So negative 3.365. And since it's less than from our alternative, we want this shaded area over here as the rejection region. Now negative 2.661, our test statistic, what we're going to test, is going to be somewhere, I'll say here. So it's definitely not in the rejection region. So we're going to say that is not in the rejection region. So we are going to fail to reject. Now we've said we're going to fail to reject, which means we still have to state our result there and answer any questions given to us. So just zoom out a little bit, and I'm going to start typing in our answer. So since we failed to reject, we can say that there is not enough or insufficient evidence to support the claim that the population mean is less than 1,000 hic. So we've tested the claim and we found that it's insufficient evidence. Now there's a second part to it, so you gotta be careful of that. Do the results suggest that all of the child booster seats meet the specific requirements? Well, we can just look at our data right up here. And we have to be careful. Do the results suggest that all child booster seats meet the specific requirements? We can see, obviously, we got one that doesn't. It's over 1,000. So we can say that no, with a result of fail to reject, and one of the seats has a hic of 1210, the requirements are not met. Don't have to go super detailed with it. Just answering the questions. Do the results suggest that all child booster seats meet the specific or specified requirements? They're not, because one is over, and our hypothesis said that we failed to reject the null hypothesis, so it's possible that the null is true. So be careful with that, especially with failed to reject, because it can be a little bit odd.